In this video, we'll look at the alcohols. The general formula of the alcohols is CnH2n plus 1 OH. Alcohols have the functional group OH. Alcohols are polar molecules. They are soluble in water because of the OH group. They are able to form hydrogen bonds with water molecules, so they are soluble in water. They are good fuels. They burn in oxygen to produce carbon dioxide and water. Next is the classification of alcohols. Alcohols can be classified as primary, secondary, or tertiary alcohols. So a primary alcohol, you have the carbon that's connected to the OH group, and this carbon in a primary alcohol is connected to one other carbon. In a secondary alcohol, the carbon that's connected to the OH group is connected to two other carbons. And for a tertiary alcohol, the carbon that's connected to the OH group, that's connected to three other carbon atoms. So that's primary, secondary, and tertiary alcohols. Next is the oxidation of alcohols. Alcohols can be oxidized into other organic compounds such as aldehydes, ketones, or carboxylic acids. The oxidizing agent is acidified potassium dichromate. In this case, the oxidation number of the chromium is 6 plus 6 in this compound. Potassium dichromate is an orange color, and when the alcohol is oxidized, it changes from orange to green. That's the color change you'll see when an alcohol is oxidized and you're using acidified potassium dichromate. Let's look at primary alcohols. Primary alcohols can be oxidized into aldehydes or carboxylic acids depending on the conditions used. So the conditions needed for oxidation to the aldehyde: heat with acidified potassium dichromate with distillation. Distillation can be used because the aldehyde has a lower boiling point than the alcohol. And don't forget the color change, orange to green. Let's take a quick look at distillation. So in here, you'll put your alcohol and your oxidizing agent and you'll heat it. The vapors will rise. As they rise up here, they'll come down this part here. They'll condense. So the vapors will condense to a liquid. The liquid will run down this tube here and come out here. So you'll collect your aldehyde here. So that's distillation. Primary alcohols can also be oxidized to carboxylic acids under different conditions. The conditions are heat under reflux with acidified potassium dichromate. The alcohol and oxidizing agent are kept together for as long as possible. So let's have a look at the reflux condenser. You put your alcohol and the oxidizing agent in here. You heat them. The vapors will rise, but as the vapors rise, they'll condense and they'll run back down into the bottom here. So the alcohol and oxidizing agent are kept together for as long as possible. So the primary alcohol will be oxidized to the carboxylic acid. Next is secondary alcohols. Secondary alcohols are oxidized to give a ketone. The conditions are heat under reflux with acidified potassium dichromate. So here's the reflux condenser again, and here's the color change, orange to green. So that will give you a ketone. A secondary alcohol will give you a ketone. And finally, tertiary alcohols. Tertiary alcohols do not oxidize, so you don't have to worry about them. And finally, a summary. Primary alcohols can be oxidized to aldehydes or carboxylic acids. The aldehyde distill with acidified potassium dichromate. For the carboxylic acid, heat under reflux with acidified potassium dichromate. Secondary alcohols can be oxidized to a ketone. The conditions are heat under reflux with acidified potassium dichromate. So all these reactions here, the color change will be orange to green. And finally, tertiary alcohols do not oxidize.